Hypothesis testing for one sample group.
Problem number 1. A survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. To test this claim, a random sample of 100 doctors is obtained. Of these 100 doctors, 82 indicate that they recommend aspirin. Is this claim accurate? Use a two-tailed test with the alpha 0.05. Given, our x is equal to 82, p hat is equal to 0.82, p is equal to 0.90, n is equal to 100, alpha is equal to 0.05. Let's begin. Step 1. Define null and alternative hypothesis. Null hypothesis, p is equal to 0.90. Alternative hypothesis, p is not equal to 90. Step 2. State alpha. Alpha is equal to 0.05. A two-tailed test. Step 3. State decision rule. Using an alpha of 0.05 with a two-tailed test, we would expect our distribution to look something like this. Looking up 0.5 minus 0.025 in our z-table, we find a critical value of 1.96. Thus, our decision rule for this two-tailed test is, if c is less than negative 1.96 or greater than 1.96, reject the null hypothesis.
Step 4. Calculate test statistic. Z is equal to p hat minus p over square root of p quantity 1 minus p over n. Substitution. Z is equal to 0.82 minus 0.90 over square root of 0.90 quantity 1 minus 0.90 over 100. Z is equal to negative 2.667.
Step 5. State results. Z is less than C. Since Z is equal to negative 2.667 and C is equal to negative and positive 1.96, so we will reject the null hypothesis. Step 6. State conclusion. The absolute computed value of negative 2.667 is less than the absolute tabular value of positive negative 1.96. Therefore, we reject the null hypothesis and accept the alternative hypothesis. Hence, the claim that 9 out of 10 doctors recommend aspirin for their patients is not accurate.
The records of patients in the hospital show that 35 of 100 patients have high cholesterol level of 240 milligrams per deciliters and above. Can we conclude that 30% of the patients have high cholesterol level? Use a one-tailed test with alpha is equal to 5%.
For the given, n is equal to 100, p hat is equal to 0.35, p is equal to 0.3, x is equal to 35, and alpha is equal to 0.05. Step 1. Define null and alternative hypothesis. Null hypothesis. There is no significant difference between the population and the sample proportions, that is, p is equal to p hat. Alternative hypothesis. The population proportion is higher than the sample proportion.
Step 2. State alpha. We use the z-test with alpha is equal to 0.05 and it is a one-tailed test. Step 3. State decision rule. Using alpha is equal to 0.05 and a one-tailed test, we have critical value of 1.645.
Step 4. Calculate test statistic. Z is equal to p hat minus p over square root of p quantity 1 minus p over n is equal to 1.09.
Step 5. State results. Since z is less than critical value, thus it does not fall in the rejection region, which means we do not reject null hypothesis. Step 6. State conclusion. The absolute computed value 1.09 is lesser than the tabular value 1.645. Therefore, we accept the null hypothesis and reject the alternative hypothesis. Hence, we can say that there is no enough evidence that 30%.
Hypothesis testing for two sample groups.
In a study of the effect of cigarette smoking to human health, it was found out that 35 among 55 cigarette smokers aged 40 years old and above is significantly higher than the proportion of smokers aged below 40 years old who suffer from cigarette-related diseases. Test the hypothesis at alpha 0. Step 2. We use the z-test with the alpha of 0.01 in 1 t-test. Step 3. From the table of the z-values, we have a critical value equals 2.33. The formula for the z-value is z is equal to p hat sub 1 minus p hat sub 2 over the square root of p hat quantity 1 minus p hat quantity times quantity 1 over n sub 1 plus 1 over n sub 2. Z is equals to 0.8357.